Remember, a cross section is just if you took a slicer, came down, and chopped off the tiniest slice, it'd be two-dimensional. You're just slicing off a piece of paper from the shape. What would it look like? Vertical, horizontal. Cross section. Let's see, Will. I would suggest having your iPad out. If you don't today, the notes are on there, and there's a lot to copy down. Okay, well, let's start. Solve the proportion. Remember how to solve these? What do you do? Cross multiply. Heard it from a couple people. Cross multiply. 5a equals what's, let's see, 7 times 91. 91, nice job. Divide by 5. A equals 91 over 5. And if we do that in a decimal, you got 18.2? 18 point, I think 2.
Yeah.
So you can do this as a decimal, but just know and pay attention, you can always leave it as a fraction. 91/5 is just as good or sometimes even better than the decimal form because it's exact. Alright, so just keep that in mind. You don't have to do decimal. You have less work if you leave it as a fraction. Okay, to find the probability of a red square, what are the couple items we need to know to find the probability of these red squares? We need to have the area of the triangle, right? So let's write that down. We need the area of the triangle. Area of the triangle, well, that's just 1/2 base times height, right? 1/2 base times height, we can do that mental math. Well, let's write it down just so we see. 1/2 times base was 13 centimeters. Height was 7 centimeters. This is base times height times 0.5. 13 times 7, we just did that, right? It was 91 divided by 2, 45 point, or 45.5, right?
Yeah.
45.5. All right, so we just found the area of the triangle. Why are we going to use that? Where is that number going to show up?
It's going to be the denominator.
It's going to be in the denominator. So we needed that. Now we should also calculate what?
Area of the blue squares.
Area
Red
of
squares.
red squares. And do we even need to worry about the blue squares?
No.
No. So just calculate the area of the red squares. Well, those are easy. What's the area of square?
1. Or
Right.
base times height.
Side times side. So side times side, 1 times 1. So that one is just 1. Side times side, 1 times 1, that's 1. So the area, 1 plus 1 is 2. We got
2
that.
divided by 45.5.
2 divided by 45.5.
It's around 4.4%.
So I heard 4.4%. Final, what'd you get? Let's use that phone for something good, right? Calculations. Let's check. I'm going to check Sebastian's answer here. 2 divided by 45.5. I got about 4.4%. Anybody else? Yeah, got a yes from DJ. Remember, got a yes from Anthony. These skills are going to show up again this week. So it makes sense to do them and get more practice. It also helps that if you're confused in math, what should you do? Ask a question, right? But to ask a question, you got to pay attention, right? Or else you don't know which question to ask. So I just want you to remember these things for your success in math. This one I was kind of disappointed that many people had trouble with. If I cut vertically, let's pay attention with how we show it with our hands. Vertically. Come from up, down, right? Up, down, or down, up. If I shaved off an up, down, or a down, up, what two-dimensional shape would I get?
Depends.
I'm saying just straight up and down, there's only one shape I'm going to get. Let's see. Let's draw it. That one comes down, goes across. Does that look like a rectangle, a square, or what? What do you guys say? You think it's a square?
Yeah.
I don't know. I kind of disagree. I think it'd be a rectangle. You could make it a square depending on the dimensions. But look at it. Do they look like the same height and width?
No.
Let's take a vote. Does it look like the same height and width? No, Bana, you will be our #1 champion. What do you think? Same height and width or different? I think so too. So I'm going to say this red shape that told me to draw it looks like a rectangle.
Great, but that says horizontal.
Horizontal one.
It does say horizontal. Okay, wonderful. Well, let's see. If I cut horizontally, so this was vertical. Thanks for catching that. I can tell somebody was paying attention there. This was vertical. Horizontal. So Liang Hang, take a look. If you go like this, horizontal, cut from left to right, what picture am I going to show? What 2D shape am I going to? Pentagon. And just look at the bottom, right? I just shave off the bottom, and I get a two-dimensional shape. It's a pentagon. Pentagon. Does that make sense? So come on, could we have gotten somebody up there to do that today? So I know all of us in here, well, all of us minus 3 still have to get our presentation points. All right. So let's make sure we get up here. All right?
Really, it's about 5 months. I mean,
5 months.
5.
Oops. Look at me, I have the wrong notes. These are the ones.
It's tough.
10-4. Make sure you have the right ones because I just noticed I have the wrong ones up. You should have 10-4 up.
Let me see what this is. Is that the one that looks like 2 homework sheets?
Yes. How many of you remember calculating surface area for a shape? How many of you remember what surface area is? Hey class, come on. It's Monday morning. Let's try and get a little bit more right into it. Let me know you're alive. Do you remember what surface area is?
I might need a refresher.
Might need a refresher. If you have a three-dimensional shape and I ask you for surface area, you have an idea already from the name what that means. What does that mean? Say it again.
The surface area.
Wow, Carl.
The-
It's coming today.
It means the area of the what?
Surface.
Of the surface. Does it mean the volume? Does it mean the volume of the entire shape?
No.
No, it just means if you go along the surface, how much area are you taking up? Right? So your table has a surface area, right? That box in front of Kira has a surface area. Volume talks about what's on the inside. Surface area talks about what's on the outside. But now we're going to get a little bit more complicated and it's actually going to make it easier for us. And we're going to talk about something called lateral surface area. So let's add some of these things to our notes because I left them blank. Lateral surface area of what shape is this? It starts with a P.
Prism.
It's a prism. So if we pay attention here, take a look. This is a prism. Prism. Lateral surface area of a prism is, all we do is we take the area along the outside, the faces. We don't talk about the bases. We talk about the area of the faces. So if you could, add that to your notes. What does it say next? Important. A lateral face is not a lateral face is not a, let's all repeat that, okay? A lateral face is not a, so faces are different, right? Well, if I asked you for the total surface area, when I ask you for the total surface area, I'm asking you to add up the lateral faces and the bases, okay? So that means surface area is lateral area plus base areas. So you might want to have that in your notes. Lateral area plus base areas, that gives you the entire surface area. Makes sense, right? Yep. Okay. So for this one, let's see. For this one, we would have to, how many faces do we have? Let's see. 1, 2, 3. Let's just say the base here was, let's just call it B. Let's call it B. Let's find out how to find the lateral surface area. I'm just going to call it L to save space. Lateral equals, well, let's see. What's the area of one face? B times H. How many of them do I have?
3.
I have 3, so I could say plus B times H plus B times H. But that's a lot of writing, so it'll probably be easier just to write 3, right, 3BH, right? That makes sense. Well, surface area, I would need to know the area of the bases, right? What shape are the bases? Triangles. So let's just give it a height for the triangle. Let's say the triangle is, give me a letter. What do you want to call it?
K.
K? Let's call it K. Thanks, Quentin. Let's see. What's the area of the bases? Bases. I know I have 2 of them, right? Top and bottom. 2 times, well, what's the area of one of those bases? I have to give this another name, don't I?
Q.
I have a top for a base and the bottom. I need a base, right? What's the base? You want to call it Q? Q. We'll call the base Q. So what's the area for that triangle? 1/2 times, so Q times, right. 1/2, it's not that messy actually. 1/2 times Q times K What happens with the 2 and the 1/2? 2 and the 1/2.
Split.
Oh, what's 1/2 of 2? 1. So what happens? They cancel. So what am I left with? QK. Well, that's for the bases, so the entire surface area. And pay attention to the notation because you have to write it correctly. Surface area equals lateral plus bases. Lateral was 3BH. Bases was QK. So there you go.
I don't put these on school.
Yeah, but I would like you to be doing them with us. Does that make sense that that's the surface area? 3 of the triangles plus that QK is 2 of the bases. Sorry, 3 of the lateral faces plus 2 of the bases. Okay. Well, let's practice this one too, because I know you struggle with pi. I know you struggle with pi. So all of us should be taking these notes. Lateral surface area. If I was to cut that cylinder open and form a net, what shape would be the lateral face? Which?
Square.
Let's see. Let's cut it open. Rectangle. Right? Rectangle. Rectangle. And then for the bases, I have 2 circles. I should probably know the area formulas for the 2 circles. What are the area formula for a circle? This one we've learned previously. I know it's pi r squared. Pi r squared. If you don't write these down, or if you don't try them, you're going to forget them. Okay? Pi r squared. For the rectangle, that one's just base times height. So let's see if we can do this on our own. Lateral area. That would just be the area of the rectangle. Good. Now this you have to pay attention to because this is a little tricky. For the rectangle, I know the height, and you also will know the, what do we call it, base, if you know this radius. So, how big does that rectangle need to be? You need to remember circumference. So look at the circle for a second. Look at the circle for a second, and what we're going to calculate is this orange length. You have a formula for doing that. Do you remember what that formula is for circumference? No, that was area. 2 pi r. To find that orange length, it's 2 pi r. Okay? So, that would tell me the base of my triangle. So I want you to look how I'm writing this. That would be this length right here. Do you agree? If you look at the color coding, do you believe that that orange circle matches that orange line? Yeah, I wrapped it around. I wrapped it around the circle. All right. And what's the, in this picture is the base, but what's the length of this part? Just call it h. So you tell me, let's see, what is the area of this rectangle? Well, I'll show you. You take 2 pi r, that's the base, and you times it by, what's the height of it? They gave it to us? H. Do you believe that that would give you the area of that rectangle? Yeah. How many circles do I have? 2. So area of the bases. Notice I'm going to put a big 2 if you're playing around. putting a big 2 to tell you why. I have two bases. 2 times pi r squared. Nope, this one's just symbolic. Total surface area, lateral plus bases. Well, let's add them up. We had 2 pi r h. 2 pi r h plus 2 pi r squared. So look, the letters that I gave you, I want you to pay attention to this here. This is important. If you are given the h and the r, all you have to do is plug it into this formula, and then you'll know the surface area if you wrote it down. If you wrote down these letters, this is a formula for your future. Always you can calculate the surface area now if you know Q, K, H, B. Couldn't I plug in all those right there and then find out what the surface area is? Alright, so imagine if you had a little prism like that in real life. You would measure a couple things, plug it into that formula, and you'd have the surface area. Do you think in some construction jobs you might need to know the surface area? Or you might need to know the volume of something? Yeah. That's why they develop these formulas, so they don't have to redevelop it every single time. Bottom, put it away. So now let's practice. Now let's practice with some real numbers. The homework that I give you tonight is based on these, so you might want to take them down. Lateral and surface area. Are all those rectangles, do they have the same area? No, right? Maybe you should color code them. I'm going to say there are 2 green rectangles, one in the front, one in the back, and there are 2 purple rectangles, one on the left side, one on the right side. So let's calculate the green ones. What's the area of the green rectangle? Well, I don't want to make it all messy. You can on yours. But I'm talking about this one right here. 9 times, what's the height of it? 3. So for that one, it's 27 feet squared. That's in the front. And in the back, I also have another 27 feet squared. Are you seeing how we did that? 9 times 3, 9 times 3. How about on the sides? What are the areas of those? It is 12. 12 feet squared. How did you do that, Leslie? 3 times 4, right? You're given the dimensions right there for those rectangles. So if I was to ask you for a lateral, and remember, lateral talks about the area of the outside, the faces. Well, let's add those up. Lateral area equals, well, let's do some mental math. 27, 27, that gives me 54. And then I also have to add on 12, so that would give me 66. And then I have to add on the other 12, which would give me 78. Yep. Lateral area equals 78 feet squared. The last thing I have to do is calculate this orange top. And I could do the bottom too, but aren't they going to be the same? So let's calculate the top and bottom. Area of the bases. That's going to be 2 times, well, let's see. What's the dimensions of that orange rectangle? And sometimes it helps to draw it off to the side. What's the length of it, the longest side? 9. What's the width of it, the shortest side? 4. So what's the area of one of them? 36. How many do I have? 2. So 2 times 36, and that gives me 72.
2.
72. All right. I gave you the lateral. I gave you the area of the bases. So the total would be adding them together. And we're just going to call that surface area. Surface area is 72 feet squared plus 78 feet squared. Let's take care of the 70s. 70 and 70 give me 140. 8 and 2 give me 10. 140 and 10 give me 150. You did that? Make sense?
Wait, how did you get
Yeah, let's hear
the
it.
lateral area again?
Lateral. I use the green rectangles in front and back,
Right.
and then I use the purple areas on side to side, and then I add them all up.
Oh, okay.
So lateral faces. Okay, before we try the cylinder, I want you to try this one on your own. Try the triangle on your own or with a partner. Try the triangular prism on your own or with a partner. This part where you can engage with each other, help each other out.
Try the prism.
Yeah.
You pick up. Never mind. Never mind. Never mind. I don't have time for you right now. I believe oh, it's empty. Okay.
To simplify things, you could debate this, but are you fine if we call those shapes the faces? We'll just say there's one place to set it up, that's it. Are you fine if we call these the faces? So this should be the lateral area if we add these all up. And then what shape are we still missing? The rectangle on the bottom, right?
Because we can't see it.
Now you could debate that, certainly, but that's just what I'm going to say to keep us all on the same track. And that one is 2 by what? 2 by 7? So do you see how this kind of helps me diagram things? And then maybe helps me calculate in a second? Lateral area. I'm just going to do mental math. Area of the triangle is 1/2 base times height. Base times height is 10. 1/2 of that is 5. How many of them do I have? 2. So their area gives me a total of 10. I get an area of, for the green. Huh?
I got it.
What'd you get?
I think
30.
34.4.
For this one?
Yeah.
34.4. Anybody else? I'll double check your work there. I trust you. 7 times 5.4. Oh, a little bit off.
What is it?
See what you typed in. It's 37.8. Yep. Nope. Okay, you gotta participate to be able to go. All right, you show me at the end, and then I'll let you go.
I still got it.
Let's add these together. 37.8 plus 35 plus 10. What'd you get? Is anybody calculating? 82.8? 82.8. Don't forget the units. Centimeter squared. Well, the only thing I need to add on is what for the total surface area?
Bless you.
Say it again. The rectangle, which has an area of 14. So let's add that on. That should be quick. 96.8 centimeters squared. Okay. Do you feel like you have the surface area down?
Usually, yes.
Yeah? Alright. I'm telling you, if you do the calculations with this, if you go through it, it makes more sense. If you just copy it down, do you think that's the best way to do it? The notes? No. You really got to follow through with the calculations and see what we're doing. So these ones are my favorite. The cylinder. Let's make a net of it so you can see what it looks like. If I unravel it, looks like that. I want you to literally write on your paper that what we just drew is called a what?
Cross section.
No, not a cross section. Be careful. It's called a net. This is called a net. All right. Let's diagram also what we have. Do I know this length yet? I do not, right? I do not know that length. Do I know this length, red? It's what? 5 inches. For the top one, too. Thanks, Bonna. 5 inches. Do I know this length in orange? You didn't even see me put it down. 6. Now, here's the tricky part, Sabir. Now we're going to find the length of that rectangle. This is the tricky part. Anybody remember what it's going to be? It has to wrap around a circle. So I'm thinking back to the circle. What's the length around the circle? The circumference. Very good. 2 pi, just r. 2 pi r. Very good. So 2 times pi times r, which is radius, which is 5. And don't put this in your calculator. Just leave it as how many pi's do we have? 5 times 2 is?
10 pies.
10 pi. So the length of that rectangle is 10 pi.
So whenever we do that,
Don't put it.
I wish I knew that first, like 8 tests.
Yeah. I don't care about a decimal. Just use pi. Now look at how easy it will be to calculate the surface area and lateral surface area.
Wow.
What shape for the lateral surface area? Rectangle. Well, the rectangle has 6 pi, 10 pi, which gives me how many pi? Oh, 60?
60 pies?
60 pi. We're hungry.
I want to make a square.
10 times, say it again. Yes. All you have, since we're multiplying, just do the 6 times the 10, that gives me 60, and don't forget the pi.
You better make a square, child.
Yep.
Literally trash.
Now, you do still have to worry about the area of the circles. Area of circles? Well, let's see. How many of those do I have? I have 2.
What does that say?
Area of circles.
Oh.
I put a 2 because there are 2 of them, and then tell me what the area formula for the circles are. Pi r squared. Pi r squared, 8. Milo? Thank you. Pi r squared. So Milo, you help us out. That gives me what? You might want to have it on your notes. pi times 5 squared, so that gives me, oh, not 2 times 5, 5 times 25. So this is 2 times 25 pi, because we did 2 of them. We did 2 of them. So how many pi's do we have? 50. A lot of pi's. To find total surface area. And if you set it up like I did, look at how nice this will be. That plus that equals surface area. So 60 pi plus 50 pi gives me 110 pi. Once I finish this last thing, yes. When you are doing the circles, just use pi. Are you going to use your calculator? No. The only time you should use your calculator on the sheet is if it says like 7.2 times 6.7, right? Like if there's decimals already. So I'm going to stop here before we get to this tomorrow. But I do want you to, as an exit ticket, so before you go to the restroom, I want you to find the area of this cylinder. Find the surface area of this cylinder as a little exit ticket.
Great.
It's a quick way to earn 5 points. You show me that you've done it, give you 5 points. If not, you get a 0.
We're going from ovals to squares. And circles.
Look at your notes.
I was actually participating in this.